Right, so let's talk about multi-threading in a more real-world use case. So, as I said, typically you have, you don't know how many tasks you need to perform, but you typically know uh, how many workers you have. So let's say in the in the restaurant. So you do know how many chefs you have. So you have like 3 chefs working in the kitchen, but you can't be sure how many simultaneous visitors that will come to your restaurant. So there could be 1, or there could be 15, and if it's 15, then 12 will have to wait to get their food. And that's what a thread pool is. So when we define a thread pool, and I should say that all multi-threaded, networking programs like SMTP server, web servers, and so on, they do have a thread pool, because the alternative, and actually it's possible now in C++. I will talk about that as well. So it's possible in C++, modern C++, nowadays, to use async. But the thing about async is that it's, in other languages, you use a lot of async. But the thing is, in C++, it will create new threads, so you can't. It's a bad thing to just to always just use async, because if you have like a network server, you're not sure, you can't tell how many simultaneous. It's like, async. That's like, okay, every time you get a new visitor to a restaurant, you hire a new chef. And all of a sudden you have like 200 chefs working during lunchtime. But what do you do after lunch when there's only need for 1 or so? So the thing is, we typically try to use some sort of thread pool, and here we create the thread pool. I will just show you the class in a minute, and we define. We also say it should have 8 threads. That's probably a bad decision. What you typically should use is you would typically have a look at the stud thread hardware concurrency. This will give you the number of concurrent threads supported, because it's not sure that that your system can support, and it's kind of stupid to have a value much more than what's supported. In some systems there are no multi cores at all. Let's have a look. Let's do this. Let's have a look at my machine. So we could yeah, why not? Let's set the breakpoint as well so it doesn't start. Let's have a look what we get. And we get 6. So as you can see, it's no meaning to try to assign more than 6, because we will never be able to run more than 6 concurrent threads. And why shouldn't we? What does it matter? Well, the thing is, actually we should probably then, this is a tip for you. Let's do this. You could also do more advanced scenarios, but the thing is, to create more threads, I mean, every thread has an overhead. That's a fact. So every thread will have an overhead, as in terms of stack memory. It has its own stack and so on, and it has, I mean, um, there is always the context switching. So I mean, as you can see, what we will do, I mean, okay, let's say like this. So this is the number of stoves in our kitchen. So why should we hire like 12 chefs when we only have 6 stoves? That would be stupid, because then we have to have some schema, some scheduling, you know. Okay, so now you two chefs switch places, so so the other chef get to use a stove for a minute, and so that's just stupid. Anyway, this is better, so let's keep it like this. So we have a pool then. Because as you can see, it's just a complete waste to create more threads than the hardware supports. All right, let's move on. So what we're doing is I am creating 10 tasks, and I'm still using this pretty worthless thing here. But I mean, what we typically do, we might call some network, I mean some API maybe to fetch some JSON or whatever, but this is just stupid, you know. But anyway, it doesn't matter. The thing is, so we are adding, I should maybe like this. No, okay, it doesn't matter. The indentation looks pretty weird. Maybe like this. Okay, so we have this pool. We will look at the code in a minute, and we are able to schedule tasks. So this is the small papers where the waiters add their the orders. So this is an order. This is, as you can see, this is a lambda. And in this lambda, we are just calling a function. But the thing is, this lambda then is, and I will show you this. It seems like it takes a task, and it does, and I will show you what it is in a minute. But the thing is, we're just taking, so we have this int. So this int we want to use inside the task. So then let me show you this. If we don't specify the I inside the brackets, what will happen is, let's compile it now, and it says that int I is not declared. Okay, the lambda has no capture default, so we are here it is. I was looking for this one. I knew it would say something like that. I is not captured. So the purpose of the brackets are actually to capture, to get the values, get the variables from the outer scope. And I mean, we could actually do like this. Then we are able to modify it if we'd like. But typically in this case, we just, okay, so this is just copy by value. That's good enough. So let's run it one more time. Okay, so now it's working. Sorry, we weren't supposed to run it. We were supposed to look at the code then. Okay, so as you can see, what we're doing is we're creating a lot of, I mean, and a server typically looks like this. So we have a server which is just, we have this loop forever, and whenever there is a call or something, I mean a request, I mean, then we would queue a new worker task. So it's really like the restaurant. What I should say also, I mean, these type of thread pools, I mean, it's a complete over engineering to use it if you just, I mean, there are use cases for the stud async as well. I mean, if you just want to fire off something just every now and then, you know, okay, so when you press this button, there should be a background task, and of course you could use stud async. I'm not going to show you that. Anyway, here's the pool then. Let's have a look at the pool. As you can see, there are okay. So there are a lot of duplicates, as you can see, and I don't feel like cleaning it up right now. Anyway, let's talk about this class then. So this is just a single class. You could typically, I mean, we do have two things to consider. So there has to be some kind of queue, right? A queue where we put all the work. There also has to be like an array or a vector of threads, and we need to keep track of them. Actually, you can see here, yeah. So the task then. The thing is, in C++, we don't need that, you know, function pointers and so on, which you might see sometimes in old C. So there is this thing called stud function. So it's a wrapper around the function, and actually kind of like the functor which I showed you a few weeks ago. Anyway, so as you can see, we are, and this is the modern way of using. We try to avoid defines, but using task equals to this, then it's the same. But it's type safe then, so it's a compiler that are managing it. So we have the thread pool then. This is the constructor, and we okay. So I don't know why. I typically when I use a vector, I just push back. It's not the end of the world. So here we reserve, because we know beforehand how many we will need. So we need like 4 or 6. So as you can see, this won't reallocate each time we push back. And the thing is, so we have a destructor, and in the destructor, okay, so we have a lot of threads in a lot of but we have a vector of threads. We also have a queue of tasks, and we also have two synchronization control variables. So because the thing is, as we will, there will be multiple threads executing at the same time, and one could be interrupted and another one could be activated and so on. It's like the printing problem. So we need to make sure that we could lock. So these are helping us to lock things and make other not as you can see. So we have some locks. So when we lock something, no one else will able to execute that code. Anyway, all right. So what we have? Okay, so we have a distractor, and as you can see, we try to join it threads in the end. Typically, I mean, the distractor typically doesn't matter so much, because in most of my applications I have never had a thread pool. I mean, local scoped thread pool, you typically have it. I mean, it will live for the whole application. But anyway, it is possible, and it's good code to have all the threads join. Okay, add task then. So this is when we try to add work to the thread pool. So we enqueue. We put them in the back of this task vector, and what we do then is we notify. So this thing is a stood condition, and it's if you ever heard about semaphores, it's kind of like the same thing. You could, yeah, so you don't have to poll a variable. So it's a thing that you could wait for in a very inefficient way. So actually, when you are waiting for this variable to change state, you are sleeping actually. So you don't have to look all the time. Yeah, has it changed? Has it changed? Has it changed? You said, okay, let me sleep and wake me up. And when you are sleeping, you don't use any resources on the server, on the computer. So and the thing is, when this tasks condition notifies, then we have this thread main, because the thing is, so when we created this, we created like 6 threads or whatever, and each of them started executing here. And what we're doing here is as long as we're not, you can see we have a variable which is possible to change if we want to shut down the program from outside. Anyway, what we do is we wait for this variable, and when it has been set, it means there will be something in the queue for us to work with. So it's a way of efficiently wait for something to be put into the queue. So in this case, we do have like 6 chefs, and all of them could be in the back sleeping. We don't have to they don't all have to be awake all the time and run and check, do I have anything to do, because they are all sleeping, and they will be woke by this variable when it's time. Actually, just one of them will be awake. Anyway, and it will work and run another task, and that's the thing actually. So it's this one is, as you can see, it's a bit smart, since it's okay. Since I'm already working, if I'm done, I could do the next one if there is more, so no one else has to, wake up, since I'm already up and running. So it's pretty smart, and the thing is, whether you understand, whether you like this code or not, this thread pool, Okay, don't think about it too much. It's not. I mean, it's not the only way to implement the thread pool. Might not be the best, but it's kind of it's working, and I mean, this is how you use it. Okay, so I think that's all about thread pools then.